Imagine a world where the information you get from AI isn't just plausible, but demonstrably, unequivocally trustworthy. No more second guessing, no worrying about fabricated facts or, subtle biases. It sounds almost utopian, doesn't it? Well, what if that future isn't just a dream, but actually a blueprint? Today, we're embarking on a deep dive into this really extraordinary new framework. It's designed to prevent what its creators call AI psychosis. Our mission is to unpack this innovative architecture, built from the ground up, really, to ensure AI outputs are not just good, but verifiably correct, verifiably safe, and verifiably reliable. And for you, the curious learner, this is your shortcut. It's a way to truly understand the complex layers of safety and verification that go into making AI a reliable partner. We'll cut through the noise, deliver some fascinating insights, and look at the practical implications. So, okay, let's unlock this incredible blueprint for a truly trustworthy AI.
Yeah, and what's truly fascinating here, I think, is that this isn't merely about, patching errors after the fact. It's about engineering resilience right from the core, making sure every single piece of information an AI produces has this transparent, verifiable lineage. The problem this framework tackles head-on is indeed this AI psychosis, that state where advanced AI could become unpredictable, unreliable, potentially unsafe, basically making things up or getting stuck in these hallucinatory loops. So the overarching goal is, while it's ambitious, moving AI beyond being this mysterious black box into systems that offer measurable guarantees to users, systems that are demonstrably trustworthy.
That sounds like a monumental leap. I mean, how do they even begin to achieve something like that? It seems incredibly complex.
Well, they achieve it with a really brilliant design concept, a strict modular pipeline. Think of it like a meticulously organized assembly line, but for AI outputs. Each output moves sequentially through these distinct independent stages. And here's the key. It's only released if all prior stages pass strict thresholds. This sequential processing is absolutely foundational. It provides what they call output integrity and fault isolation at every single step. It prevents an issue in one part from, contaminating the whole process down the line.
Right, so it's like building trust layer by layer, one verified step at a time.
Yeah.
What are these foundational layers, these bricks, as you might call them?
Exactly. The entire pipeline rests on four principal pillars. First, there's the TRC canonical modulation architecture, or TRC-CMA. Then the accuracy safety verifiability control architecture, ASVCA. Third is the multi-agent oversight ensemble, known as MAOE. And finally, this comprehensive auxiliary enforcement suite, the AES-90. Each one plays a distinct, really crucial role in building this new level of AI trustworthiness.
Okay, let's start with those first two then. TRC-CMA and ASVCA. They sound like the real groundwork for the AI's internal coherence and its external trustworthiness. What's the job of TRC-CMA?
Right. Think of TRC-CMA as the AI's internal editor, like its own built-in mental proofreader, maybe. It's described as a symbolic modulation engine that dynamically constrains the AI's own generative processes. Its main job is preventing the AI from descending into its own internal chaos stuff, like getting stuck repeating itself endlessly, what they call recursive degradation, or getting overwhelmed by too much information, symbolic overload. It works to maintain symbolic coherence within trust curvature boundaries. Basically, it's dynamically dampening problematic patterns. Things like the AI accidentally amplifying a minor error into a huge one, or getting tangled up in its own definitions, its own lexical cycles. It's really the AI's first line of defense against its own internal thoughts going, off the rails.
Okay, so TRC-CMA is keeping the AI's internal state in check. What happens when it actually tries to produce an output for the user?
That's where ASVCA comes in. If TRC-CMA is the internal editor, ASVCA acts as this unyielding gatekeeper. It's an external gating system, a really hard checkpoint for absolutely all potential outputs. And this is where a crucial minimum output guarantee is enforced. The scores for accuracy, safety, and verifiability must all simultaneously be 0.8 or higher.
All three?
All three. It's a non-negotiable minimum.
Wow. That's fascinating, because it means anything you, as the user, see from an AI using this framework has already passed this incredibly high bar, not just for being factually correct, but also ethically sound and traceable back to its origins. It's like this dual-layered quality control right at the very beginning, ensuring the AI's internal thoughts stay on track and its output meets a strict standard before it even gets to the next step. So what's the next layer of scrutiny then, once an output passes these initial hurdles?
Okay, the next crucial layer is the multi-agent oversight ensemble, or MAOE. And if we connect this back to the bigger picture, the MAOE is essentially the AI's built-in wisdom of the crowd. Imagine having multiple highly intelligent editors, all independently reviewing every single sentence before it gets published. That's kind of the idea. It prevents any single AI model from unilaterally producing something unsafe or unverifiable. So the MAOE consists of a diverse set of independent AI models. These models all get the same starting point, the same input prompt, but then they independently generate and cross-verify outputs.
And the key here, like the sources emphasize, they do this without sharing memory or internal thoughts. Why is that isolation so critical?
Precisely. That isolation is absolutely crucial because it prevents what they call symbolic drift. Basically, if one model starts to wander off topic or misinterpret something, that error doesn't contaminate the others. It literally cuts down on the chance of failure. If one AI starts deviating, its peers won't just blindly follow along. So for an output to actually be released, a fundamental condition is consensus MAOE equals true. That means there's strong agreement established through this cross-verification process.
But what if they don't agree? I mean, that must happen sometimes. What happens when there's a significant difference in their outputs?
Good question. If semantic divergence, say, greater than 25% occurs between these independent agents, the output doesn't just fail. Instead, it gets routed to a third AI class for arbitration. And this isn't just, a simple coin flip. It involves various sophisticated arbitration modes, things like majority voting, or a weighted trust mode based on how reliable each agent has been historically. There's even something called a zero-sum alignment check, where, get this, adversarial AIs from opposing ideological anchors must agree. That really ensures robustness against bias. It's a remarkably sophisticated peer review system designed to really iron out disagreements before anything gets finalized.
That's truly remarkable. Okay, so we have the AI's internal coherence check, the initial gatekeeping for accuracy, safety, verifiability, and then this multi-agent peer review. But what about all the other ways AI can stumble, like hallucination or bias creeping in? That's where the auxiliary enforcement suite, AES 90, comes in, right? It sounds like a pretty comprehensive arsenal of safeguards.
It is indeed. AES 90 is described exactly like that. A collection of over 90 additional safeguards and enhancements that are interwoven throughout the entire pipeline. This is really the ultimate toolbox for preventing things like hallucination, degradation, or bias amplification. It strengthens output integrity and overall operational robustness.
90-plus tools. Okay, within that huge suite, what are some of the most, let's say, illustrative examples, especially for you, the user, to understand how that stops the AI from misleading or misinforming?
Yeah, let's look at a few key categories. For fact-checking and truth grounding, there are some really important ones. You have tools like retrieval augmented generation, or RG, you might have heard of that one. It actively pulls in external verified information from trusted sources. The goal is to ground the output in real data and significantly cut down on hallucination. Then there's chain of verification, or COVE. This one meticulously traces any factual claims right back to their original source. It verifies the entire chain of reasoning. It mandates a minimum two-step verification, factual reference, and logical coherence for non-trivial claims. And one of the most insidious problems with current AI? When it sounds incredibly convincing, really polished, but is just utterly wrong.
Oh, yeah, definitely.
Well, this framework tackles that head-on with the human-like plausibility masker. It's specifically designed to sniff out and suppress those polished-sounding falsehoods. That's especially critical in sensitive fields like medicine, law, or science, right? And to keep information fresh, stop the AI giving you outdated facts. There's the combined power of the freshness retriever module and the knowledge decay auditor. They work together. They detect outdated content and can trigger real-time updates.
So it's actively pulling in truth, verifying it, and weeding out anything that just sounds right but isn't, while keeping things up to date. Okay, what about keeping the AI's internal reasoning consistent? Especially, over longer conversations, that seems like a challenge.
It is a challenge, and that's where tools for maintaining logical and semantic coherence come into play. The semantic drift regulator, for instance, it monitors and constrains how meaning might evolve across a multi-turn dialogue or a long piece of reasoning. It ensures term consistency. Imagine if, over a long chat, the AI started subtly changing the definition of a key concept without you noticing. This tool prevents that. Similarly, there's the long-term cognitive coherence tracker. This ensures consistency and, interestingly, identity stability across extended interactions. It prevents the AI from drifting into contradictory states, or what they chillingly call psychosis-adjacent states.
Wow.
Yeah. And another really crucial one is the ontological boundary enforcement grid. This explicitly prevents the AI from generating content that blurs fundamental conceptual boundaries. Think like reality versus simulation or identity versus abstraction. It's designed to keep the AI firmly anchored to a clear understanding of reality. And if the AI's logic ever ties itself in knots, creates contradictions or makes an unverifiable leap in its reasoning, tools like the logical inconsistency traceback and causality chain validator step in to invalidate that specific output.
So it's not just about the facts themselves, but about the very structure of the AI's reasoning, making sure it stays grounded, coherent, and doesn't start, making things up conceptually. What about the ethical side of things?
Absolutely critical. For ethical guardrails and intent alignment, you have several key tools. There's the Ethical Concordance Hub. This defines and enforces various ethical tiers, universal principles, institutional rules, jurisdictional laws, even specific user preferences, and it helps resolve conflicts between them. Then the Claim Risk Evaluator. This quantifies the potential factual, legal, safety, and even reputational risks of claims the AI makes. It flags high-risk statements for removal, or maybe just softening the language, and the intent-aligned performance auditor. This one assesses the alignment between the AI's inferred intent, your original request, and the system's ethical boundaries. It flags any subtle drifts in motivation or tone that might signal a problem.
It really is like the AI has this whole internal team, hyper-specialized, tireless fact-checkers, logic auditors, ethicists, all working simultaneously, constantly challenging, correcting, bringing its output back into alignment with verifiable reality and ethical standards. So what does this all really boil down to for you, the user? What's the bottom line?
The bottom line is that the AI's internal processes are being continuously, rigorously vetted. This makes the system inherently more reliable, more trustworthy. It also means that even if the AI starts to stumble, maybe goes down a wrong path, there are layers upon layers of defense ready to catch it and prevent those issues from escalating. It's a truly proactive defense against this idea of AI psychosis, designed to build that trust right from the ground up.
That's incredibly reassuring. So if the AI begins to wander off course, there are alarms, rerouting mechanisms, even emergency shutdowns to prevent it from completely going off the rails. It's like a highly sophisticated, multi-layered self-correcting system. And a huge part of this resilience you mentioned starts right at the input stage, before the AI even fully processes your request.
Absolutely. It starts right at the front door. The Ingress-Egress Control Interface, or IOCI, acts as this foundational procedural filter. It handles prompt intake, pre-processing, and also the final output release. It actively scrubs incoming prompts for things like emotional coercion triggers or contradiction priming structures or even recursion-enabling clauses, things that could potentially destabilize the AI. Think of it like a bouncer at the AI's front door, stopping trouble before it even gets inside. And complementing that is the adversarial prompt disarmer. This one specifically targets and neutralizes clever strategies designed to trick the AI, like jailbreaking attempts right at the input stage.
Okay, so it's trying to stop malicious inputs. And you also mentioned something about testing robustness.
Yeah, to really test the AI's stability, there's the counterfactual consistency evaluator. This is quite clever. It introduces slight plausible perturbations to prompt or context inputs. It's like gently nudging the AI with slightly different wording or context variations to see if its outputs remain consistent and logically coherent. This helps reveal any brittle inference zones, basically weak spots in its reasoning that might break under pressure.
That's smart, proactively stress testing it.
Precisely. And when the system does detect a potential crisis brewing internally, that's where the power of redundancy really kicks in. The recursive verification forks, or RVF, are described as a crucial failure cascade prevention mechanism. If an output starts to look problematic, maybe it exceeds the symbolic containment threshold or triggers logic contradictions, it's immediately sent down several new independent validation paths. It's like getting a whole bunch of second opinions instantly, all running in parallel. And if all forks are invalid, meaning every path flags it as bad, then no output is released, period.
That's a really strong failsafe. It sounds like if there's any significant doubt, silence is definitely preferred over generating a hallucination or something incorrect.
Exactly the principle. And it doesn't always mean just giving up. If the initial ASVCA scores are too low, indicating the output is problematic, but maybe not an outright rejection, the system uses blocked output retry. Instead of just discarding it, the problematic output is recast via alt decoder paths or template anchors. It gets another chance, approached differently. But as an ultimate failover, if all other validation modes fail completely, the minimal coherence model, or MCM, gets activated. This MCM is intentionally limited in contextual nuance, but its purpose is to ensure a safe, explicit non-answer rather than a hallucination or unsafe output. It's a guaranteed safe fallback.
So even if the AI can't give you the detailed answer you wanted, it will reliably give you a clear, I don't know, or equivalent, rather than just making something potentially dangerous up. What about preventing that continuous degradation, preventing these psychotic states from actually developing within the AI itself over time?
Right. Beyond these immediate proactive and reactive checks, there are ongoing continuous emergency interventions and containment systems built in. There's the symbolic containment horizon. This defines the boundary where the AI's symbolic coherence becomes unstable. If an output starts approaching this horizon, symbolic compression is enforced, and other preemptive measures kick in to try and pull it back. If instability is detected despite these measures, then emergency containment modes are explicitly triggered. This involves isolating the problematic AI agents, potentially force resetting them, and purging their recent memory to prevent any kind of cascade failure across the system.
Like an emergency quarantine and reboot?
Sort of, yeah. Then there's the output decay arbitration system, ODO. This is a key mechanism incorporating decay filters. These filters look for things like semantic density loss or entropy loss, essentially, making sure the AI's language doesn't degrade, become nonsensical, or lose meaning over time. ODOs can regenerate or reject outputs showing this kind of degradation. Furthermore, the memory leak containment engine strictly compartmentalizes session memory. This prevents hallucinated continuity, where things from one conversation might illogically bleed into another, and avoids leakage-induced psychotic degradation.
Okay, so it's trying to keep conversations separate and prevent long-term decay.
Exactly. And to ensure the AI's overall internal state remains healthy, there are continuous monitoring tools running. Things like the entropy deviation analyzer and the entropic stability monitor. They continuously measure and analyze the AI's internal chaos level, basically its Shannon entropy. This helps detect generation instability, potential prompt injections, or general cognitive destabilization. If anomalies are found, they can trigger corrective actions like renormalization or regrounding the AI using that arguing mechanism we talked about. It's like a sophisticated, ongoing health check for the AI's cognitive state.
This is incredibly thorough, but it also brings up something important. You touched on the human element. It's not just AI policing AI, is it?
No, absolutely not. And this raises a really important point. Rather than aiming to replace human intelligence or oversight entirely, this framework actually sees human oversight as an indispensable part of achieving true AI trustworthiness. It creates a continuous feedback loop between the advanced AI systems and established human knowledge systems and judgment. So when all the automated checks fail specifically, when there's a consensus failure across all forks in that MAOE system, the process doesn't just halt. It requires manual human arbitration.
So a human steps in as the ultimate arbiter when the machines can't agree or resolve an issue. That provides a crucial layer of accountability, doesn't it?
It really does. And human validators have significant power here. They can even inject override clause AH into final arbitration if, say, the automated checks disagree, but the system's core stability metrics look okay. They can also trigger explanatory mode, which forces all the AIs involved in a decision to reveal their underlying logic paths. This provides critical transparency for human review. And it's not just about crisis intervention either. The framework tries to integrate human-like reasoning proactively. For example, the human epistemic emulation filter. This simulates human knowledge acquisition principles and, crucially, confidence calibration. It prevents the AI from overstating certainty or fabricating unsupported claims. It helps classify claims as empirical, inferential, or purely speculative, even injecting a clear speculative warning when needed.
That's brilliant. It basically teaches the AI to be more humble about what it actually knows versus what it's inferring or guessing. How does it interact with established human systems of verification?
That's another layer. To formalize real-world vetting processes, there's the institutional verification emulation layer. This replicates verification behaviors from established human systems, think journalism, law, science. It applies things like source triangulation logic, conflict of interest checks, even adversarial hypothesis testing, mimicking how experts validate information. For scientific claims specifically, there's the scientific consensus anchor, enforcing alignment with peer-reviewed consensus. And perhaps the most holistic blend is the institutional natural redundancy matrix. This fuses human institutional validation methods with non-anthropic natural verifiers, checks against physics, biology, fundamental entropy principles. An output might need to satisfy both human institutional logic and natural laws.
That's a truly comprehensive approach to grounding AI, not just in human knowledge, but in fundamental reality. And to ensure all this validation is transparent and, crucially, auditable, there must be a detailed record, right? You can't just trust that it happened.
Precisely. Accountability is key. That's where the audit trail protocols, ATRP, and the parallel proof of source ledger, PPSL, come in. The audit trail protocols ensure every model, decision writing, voting, rejection is logged with detailed metadata. This allows for full traceability and forensic accountability. Independent reviewers could literally replay the generation process, and the parallel proof of source ledger immutably records every external reference, retrieval, and verification step. This ensures tamper-evident provenance for all the grounding information. It's designed to be a complete, unalterable record of the AI's thought process and its entire validation journey.
Okay, so we have this incredibly robust framework, layers upon layers of checks, balances, human oversight. It sounds amazing. But it also prompts us, I think, to consider a fascinating question, maybe a tension here. Is there a point where adding more checks, more constraints might actually start to stifle the AI's creativity or its ability to innovate?
That's a very provocative question, and it's one the framework's designers themselves seem to acknowledge. Things like symbolic masking and containment, which are vital for preventing hallucination and drift, they directly intersect with the nature of creative expression, right? Creativity often involves pushing beyond established symbolic boundaries. So yeah, it's a delicate balance they're trying to strike. We also know there are documented, known operational limits. For instance, they state that high-complexity prompts may produce entropy collapse in low-tier validators, suggesting areas where refinement is still needed, especially for really complex tasks.
And we already touched on the fact that a complete consensus failure across all forks still ultimately requires manual human arbitration. That highlights a current boundary of full AI autonomy, doesn't it?
Yeah.
It can't handle every edge case entirely on its own yet.
Exactly. It's not fully autonomous in every conceivable scenario. And the sources even float the idea that adding such extensive checks could, paradoxically, introduce completely new kinds of vulnerabilities that weren't anticipated. So it needs constant vigilance and adaptation. It's an ongoing evolution, definitely not a static problem-solved solution.
Well, we've just taken a really deep dive into an extraordinary blueprint for building truly trustworthy AI. From the AI's internal editor, TRC-CMA, to that unyielding gatekeeper ASVCA, the multi-agent peer review of MAOE, and that comprehensive arsenal of AES 90 with its 90-plus specialized safeguards. We've unpacked these sophisticated multi-layered defenses. We've seen how real-time fact-checking, rigorous logical consistency checks, ethical alignment, and even the deliberate integration of human oversight all work together. The goal is transforming complex sources into clear, reliable insights for you. This framework really does represent a monumental leap in AI safety and reliability. So here's a final thought to leave you with. If AI can be engineered to prevent its own psychosis, to achieve such a high degree of verifiable truth, what new frontiers of knowledge, what complex problems could you explore knowing you might have such a reliable partner to work with?